In this lesson, we'll talk about polynomial and radical equations. What I want to do is give you a couple of techniques that you can use to solve equations when the degree is more than 2. The first technique is what we call an equation that is quadratic in form, or sometimes referred to as quadratic-like. If it's quadratic in form, what it means is you've got the same a, b, and c, but there's a special expression going on in the problem where the first expression is the square of the middle expression. And so when this happens, you can solve the equation by treating it like a quadratic and factoring it, or even using the quadratic formula like a quadratic. Here's your example. What I want to point out is that if a is x squared, then we would get that a squared would be x squared squared, which is x to the fourth. But look, there it is, x to the fourth. So this is quadratic in form. The criteria that you'll always find to spot that it's quadratic in form is that this factor can be obtained by squaring this factor. And sure enough, x to the fourth is the square of x squared, so this is what we call quadratic in form. So what I'm going to do is I'm going to think of this as a squared minus 13a plus 36. Now I can just factor it. I want two numbers that multiply to 36 and add to negative 13. What do I get? Well, a minus 4 and a minus 9 do the job. So I set each one equal to 0. And I get a equals 4 or a equals 9. But what was a? A was x squared. So I get x squared equals 4 or x squared equals 9. So simply put, you just now take the square root of both sides, and don't forget that plus or minus. Square root of 4 is 2. Next one, square root of 9 is 3. So these are my 4 solutions to this equation. And so the strategy simply is identify something where the square of the middle variable factor is the first variable factor. When that happens, you can use regular techniques just like it's a quadratic equation. Next example. I think it's pretty clear in this problem that a would have to be x squared plus 2x, and this right here is a squared immediately. So let's write down that a is x squared plus 2x. Then we can reduce this to a squared minus 7a minus 8 equals 0. Now just factor it. A minus 8 times a plus 1 equals 0. A minus 8 equals 0, or a plus 1 equals 0. So we get a equals 8, or a equals negative 1. Let's plug it back in. X squared plus 2x equals 8. X squared plus 2x equals negative 1. We got two quadratic equations to solve. That's fine, let's get them both equal to 0. I'll just treat it one equation at a time. So this one I can factor to be x plus 4 times x minus 2. Well, if x plus 4 was 0, then x is negative 4. If x minus 2 is 0, then x equals 2. There's part of your answer. If I add 1 to both sides in this problem, this one factors to be x plus 1 times x plus 1. So I really just get one solution out of this one. If x plus 1 were 0, then x would be negative 1. And so those are the 3 solutions to this equation. Technically 4, because this one showed up twice, but that's not something we pay attention to in this course. Next example. Here's another one that you can do just with general factoring techniques. Sometimes you can use the same factoring techniques that you've used on other problems with larger problems. So let's take this one for example. If I start out by subtracting 4 from both sides, then what I can do is I can factor this. Note that I really have this going on. X to the 4th is x squared squared. 4 is 2 squared. So by my difference of squares formula, this is x squared plus 2 times x squared minus 2. So let's factor it with that. So I can factor it just like any other equation. Now I get x squared plus 2 equals 0, or x squared minus 2 equals 0. So we'll subtract 2 from both sides here, and add 2 to both sides here, and then take square roots. Do it the same way we have in the past. Plus or minus square root of negative 2, plus or minus square root of positive 2. This one's done. But for this one, let's write it as plus or minus I times the square root of 2. And there are all of our solutions for this particular problem. Lastly, we've got this example. This is an example where sometimes you can use factor by grouping to solve a polynomial equation. So factor by grouping, remember, very, very important, is when you use grouping, this has to be a plus in between. So I wrote it as plus and negative like I usually do. In the first term, I can factor out an x squared, leaving me with x plus 2. In the second term, I can factor out a negative 4, leaving me with x plus 2. One factor is x squared minus 4. The other factor is x plus 2. And hey, look, it's a difference of squares. This is x plus 2 times x minus 2. And I still have another x plus 2. I'll set each one equal to 0. And I'm not going to bother with the last one. There's no reason to write it twice. But there is multiplicity 2, which, like I said, is not something we have to worry about in this course. I get x equals negative 2, or x equals positive 2 as my two solutions. A radical equation, simply put, is any equation that involves a radical, such as a square root, a cube root, or even rational powers. Any of those are what we classify as radical equations. And so let's go through the steps to solve a radical equation. One of the things we have to do is we get one of the radicals on one side by itself. Now, this is a very important step, even more so than some of the other problems we've done in the past. When you get it by itself, that does sometimes mean that you've got other radicals that aren't by themselves. But for our case, we're only going to do problems where there is one and only one radical, and we're going to make sure that it's a square root. It's possible to work with more than one radical, it just takes a lot of work. What we do is if we have the radical by itself, we then raise both sides to a power that's going to undo the radical. So since we're doing only square roots, what we're going to do is square both sides. Next, we simplify and solve the resulting equation. You'll get some sort of polynomial equation to solve. And then when you're done, you need to check your answer. By checking your answer, you're making sure that squaring both sides didn't create something that wasn't actually a solution. Remember, when you square both sides, it treats negative numbers and turns them into positive numbers, which might cause issues in your process. Now, I want to show a quick example before we go into a regular one that will show you exactly why the check step is important. Let's just go ahead and square both sides of this equation. We just get x on the left, and negative 1 squared is 1. So let's plug that back in. The square root of 1, does that equal negative 1? No, it doesn't, because the square root of 1, that's always just 1. Clearly, that's false. We don't have that. That means that there's actually no solution to this equation. And so this one is extraneous. There's no number that you can plug into the square root of x and get a negative value. So no solution is what we'll put for this one. Now, let's do one of our regular examples. So the first thing you need to do is get a radical on one side by itself. So I'm going to start by adding x to both sides. I get the square root of 4 minus x equals x plus 2. And now that the radical is by itself, I'm going to square both sides of the equation, and I'll end up with 4 minus x on the left, and on the right, this is the part where you need to be careful. Remember, when you square a binomial, you don't just distribute the square, you write it like this. So x plus 2 squared is equal to x plus 2 times x plus 2. We need FOIL to do these. Don't try to take a shortcut because the shortcut does not work. We get x squared plus 2x plus another 2x is 4x plus 4 is the last term. Now I will point out that there is a shortcut that you can use, and it's a formula we've used in the past. Namely that you can square the first term plus twice the product plus the square of the last term. And you'll notice that works here. X squared, the product is 2x, so twice that is 4x, and the last term squared is 4. Long story short, when you're doing these, make sure that you end up with 3 terms when you square a binomial. Don't lose this middle term because you're trying to make up a shortcut that doesn't work. So now, this is a polynomial equation. We need to get it equal to 0. So I'll subtract 4 from both sides and add x to both sides. And that turns out to cancel the 4's. So I'm going to flip the sides here and get x squared plus 5x equals 0. If I factor that, I get x times x plus 5. And so what this gives us is x could be 0, or x could be negative 5. Now, that's the end of step 3. Remember, for these, step 4 is you need to check your answer. So what I'm going to do is I'm going to plug these back in. Square root of 4 minus 0 equals 2. It's important when you do these to make sure that you plug the value back into either the original equation or some variation of it that happened before you squared both sides. The original equation is probably your safest bet. So I want to know if this equation is true. Well, 4 minus 0 is 4. Minus 0 doesn't do anything. So is this equation true? Definitely. Let's try x equals negative 5. Well, we get the square root of 4 minus negative 5 minus a negative 5, and we want to know if that's equal to 2. So here I get the square root of 9. This becomes a plus 5, and we're asking if that equals 2. Well, square root of 9 is 3, and 3 plus 5 is definitely not 2. So negative 5 is extraneous. It does not solve the equation. And by the way, one kind of cool thing that shows up is notice that if this 3 were actually negative 3, this equation would be true, wouldn't it? That's actually where the issues arise, is that when you square both sides, you could get an answer that appeared from the negative value of this square root, even though square roots have to be positive when you write them in this manner. Let's do another example. Now for this one, I'll go ahead and subtract 2 from both sides to get the square root by itself. And I get the square root of x squared minus 4x plus 4 equals 3x minus 2. And now again, we'll square both sides of the equation. And we need to be careful again when we're squaring this term. Use your correct algebra. The left side's easy, but for the right side, I'll let you write this out any way you want to check me behind it, but I'm going to use the special formula. You get the first term squared plus twice the product. Negative 6x becomes negative 12x plus the last term squared. That's usually the easiest way to solve these. Let's get all the terms on one side, get it equal to 0, and look, the 4's cancel again. I think I'll get them on the right side because I don't want a negative value for my leading coefficient. But that's irrelevant. You can pick the other side if you want to also. So that puts everything on one side for me, and I'm left with 8x squared minus 8x equals 0. I can factor out an 8x. That leaves me with x minus 1 equals 0. So if 8x equals 0, I can divide by 8, and I get x equals 0. Or if x minus 1 equals 0, I get x equals 1. Let's check it. If x equals 0, I get the square root of 0 squared minus 4 times 0 plus 4 plus 2 equals 3 times 0. Is that true? Well, on the inside of the square root, I get the square root of 4 plus 2, and I get 0. And so the question is 2 plus 2 equal to 0? Definitely not. So 0 is extraneous. That's not part of our solution. However, I will point out again, just like I did in the last one, if this square root happened to be negative, it would have actually held. That's the trick behind these and why you have to check your answer. Let's try x equals 1. So we have 1 squared minus 4 times 1 plus 4 plus the 2. Let's see if that's equal to 3 times 1. Well, in here I get 1 minus 4 plus 4, which is just 1, plus 2. We want to know if that's equal to 3. So we end up with 1 plus 2 equals 3? Yeah, that's definitely true. So x equals 1 is indeed a solution to this problem.